Today I will discuss about pressure measurement gauges. These gauges will measure the or find the pressure value in the fluid or liquid, okay, inside a tube or inside a tank like that. And now here we are using two types of gauges. One is manometers. We are using these manometers in labs, and second one is mechanical gauges. Again, manometers are dividing into five parts. Let us see: piezometer, simple manometer, differential manometer, inverted differential manometers, and micrometers. First two, these two are using for finding the p value at one point in the flowing flow or at static flow also. Let us assume water or fluid or gas is moving like this. If you want to measure at one point, at a point, we need to measure the p value. We are using these two types, piezometers and simple manometers. We can find PA by connecting these instruments, okay, or these gauges. PA we can find inside the flowing fluid or static fluid. And these remaining three, we are using for finding the pressure difference at input and output. 2 points we can find the difference of pressure. Let us assume here one pipe I am taking. Again I am connecting one flow meter, which will find how much discharge of water is taking place. This is input A and this is output B. We can find the pressure between input and output, difference between input and output. Okay, PA minus PB means difference in pressure value we can find by using the three instruments. Okay, next three. Today I will discuss about piezometers and simple manometers, and in next video I will explain these three. Take piezometer. Now piezometer has one pipe, L-shaped pipe, small diameter. Now this pipe has one bulb, okay, glass bulb and glass pipe. This pipe, let us assume this is the center. You can call it as piezometer tube also. Okay, and if you are doing the center lines, if you are taking a point, now I will show you practically how this glass tube is connected to the pipe flowing fluid. Let us assume in this pipe water is flowing. Okay, I need to find the P value at this point. Okay, so at a point, what I am doing is I am taking small tube, open tube. Now I am connecting at a point. I am connecting the piezometer like this. This is a big pipe, water is flowing in it, so I need to find the P value inside this pipe, okay, here at a point. So I am connecting one tube, open tube, at the center of this piezometer. So while flowing water is going here and it is going in this piezometer tube also. Okay, because of capillary effect it will raise the height. So here one pipe, center line here, and this is height because of capillary effect, how much rise of liquid inside this tube. Okay, H, and this is the transparent tube glass, so that we can see the level of liquid. So we can measure by using the scale here, H value. If we are taking a point, PA we can measure by using rho GH, where rho is density of this liquid, flowing fluid. Okay, it is density, and height is H, and the G value is 9.81. From this we can find the PA value. So by using this piezometer tube, we can find gauge pressure. And because it is open to the atmosphere, okay, negative gauge pressure or vacuum pressure we can't find by using this. Okay, so it is the main disadvantage of this. Vacuum pressure we can't measure, can't be measured by using this piezometer. Okay. The improved version of piezometer is simple manometer, like this. Here it is also it has also one glass tube here, but we are connecting like U-type tube, glass tube here. Okay, instead of one liquid previously, here one liquid is flowing, whatever flowing fluid is there inside the pipe, that fluid, and one more liquid we are taking here. It is some Hg, mercury we can take, Hg. Okay, two different density liquids we are taking here, while in piezometer we are taking only one flowing fluid liquid, only one density liquid. Here we are taking two density liquids. Density I am taking rho 1 here. For this density is rho 2. Okay, and another limb is here open to the atmosphere. These simple manometers can be used for finding the gauge pressure as well as vacuum pressure. This arrangement is showing it, you can find the gauge pressure. Okay, if at low pressure this will come here. Okay, the entire mercury will come this side. It is the vacuum pressure. Now I will write how to find the PA value. Let us take this is the A point. How to find the pressure by connecting this to the pipe. Now I am writing the equations. Here two density liquids are meeting. I am taking, this is the datum line, Z and Z. Okay, just write down for reference line. Now I am taking, this is the left hand side, this is the right hand side. I am first writing the equation of left hand side. Now let us take this is PA. We don't know that value, PA. Plus, what is the height? Because of this height, some pressure will be there. So pressure formula is rho1 G H1. Because of first liquid, rho1 density. Because of that, I am writing the equation like this. PA is this unknown value plus, because of this height, some pressure is there. That formula is rho GH, but rho is I am taking rho1 G H1. Now here we can't take equation because this side and this side is symmetrical. Left hand side and right hand side has formula has cancelled, is equal to this side I am taking. Okay, which liquid we are taking? rho2. Because of this height, some pressure will be there. That pressure is rho2 G H2. Rho2 G H2. Okay. Now here we need to find PA value. PA is equal to rho2 G H2 minus rho1 G H1. Okay. This is the equation for the finding pressure at A point. Now these values will be given. Rho2 mercury density and G value 9.81. H2 we can find by using the scale here how much height. Similarly, minus, if water is given, rho value 1 we can take here 9.81. H1 is by using the scale we can find this value. Like that we can find PA value at A point. Okay, this is the formula for finding the P value in simple manometers. Now take the simple manometer. I am connecting to one pipe to this simple manometer at this ball B point. I need to find B value, pressure at B point, that is PB. Okay, we need to find. Here mercury level is coming automatically like this. Okay, so previously mercury in previous case in measuring gauge pressure, mercury got some height. Okay, and in this case let us assume mercury is coming like this. This side of height is more than this side. Okay, now how to write the formula for this? Here there is no mercury. From this it is starting, so I am doing just one line, reference line, ZZ, datum line I am writing. Okay, and we need to find pressure. Take the first left hand side equation is equal to right hand side equation. Okay, LHS is equal to RHS. Left hand side is equal to right hand side equation. First take left hand side. What is PB? It is unknown value, we need to find it. Plus, and here this is rho1, flowing fluid density, and this mercury density take rho2. Rho1 has some H1 height, rho2 has some H2 height. Okay, now take, because of this H1 it has some pressure, rho1 G H1. This side, this mercury height is also in the left side, that's why I am keeping plus here. Rho2 G H2, rho2 G H2 is equal to, is there any height in the right hand side? There is no height, that's why I am keeping 0. Okay, and this part is balanced because it is symmetrical, whatever this side and this side also same, that's why we are not considering any equations in this part. Okay, from this find out PV. Minus of these two terms will go this side, minus will come rho2 G H2 plus rho1 G H1. Both terms will get minus, so I am removing this minus here this side. So this one, whatever value is coming, it is negative. Okay, so negative pressure indicates the vacuum pressure at B point. Okay, so whenever we see this type of arrangement, only mercury height is in only one side, means that is left hand side. By seeing this diagram we can tell it is the vacuum pressure. Okay, we can't tell the value, but we can tell it is a negative pressure. By using these equations we can find the pressure value. If the height is, this side height is more, whatever value is coming PA, it is positive, that is the gauge pressure. Okay, so here PA is coming positive. Positive value means gauge pressure. Gauge pressure means which is more than atmospheric pressure. If you are getting PB negative, it is the negative pressure, means vacuum gauge pressure. Vacuum gauge pressure means it is less than atmospheric pressure. By seeing this diagram we can find out it will give the negative pressure. Okay, so today's topic we took piezometers, and then simple manometers, and then simple manometer for finding the vacuum pressure. And in next class we will see the differential manometers. Okay, these manometers will find only pressure at one point. Okay, at single point. In next class we will see differential manometers. Those will measure the pressure between input and output of a pipe. Disadvantages of this manometer, simple manometers, is it can measure P value, pressure value only at one point. Okay, if you want to measure at two different points in the same pipe or in the flow meter, so we can't find differential pressure by using this. In next class we will see the differential manometers and how to find the P value by using the equations. Thank you for watching.